Okay, here are a few examples of different triangles you might see, and we're going to go over how to determine which of your two formulas to use in each case. So in the first example, notice that in my law of sines, you always have sine of the angle A across, which is across from side A, that to make a ratio. The only angle I have here is 65. Since I don't have the side across from that, I'm not going to be able to use law of sines. So instead I go to law of cosines, and just notice here there's one angle, angle C, and across from that is side C, and that has to be on the other side of the equation. So if 65 is the angle I have to start over here with my A on the other side. So I would say A squared equals, and then use my other two sides, 10 squared plus 13 squared, minus 2 times 10 times 13, and then cosine of, since I went with A, that would be angle 65 degrees. And then at this point I can just type that all in the calculator. 10 squared plus 13 squared minus 2 times 10 times 13 cosine 65. And so A squared is 159, and I just take the square root of that, and I get A is 12.614. All right, in the second example, notice in my law of cosine, since I have all three sides, then I need to have at least two of them in the picture. Here I've only got one, but the good news is I have that 28 that I have is across from the 86, which means I can use law of sines. So for this one, I would start with the angle inside that I have. I would say sine of 86 degrees over 28 equals, and then since 64 is the only other angle I have, I'll put that one, sine of 64, and that would have to go over this side over here, so side D. And now I could cross multiply and solve, so it would be 28 sine 64 equals D sine 86. And then I just divide by sine 86, and I can solve. So 28 sine 64, close my parentheses, divided by sine of 86. And I get 25.228. So D is 25.228. And then I can go from there. All right, third example. This time, notice I don't have an angle and a side across from each other like I did in the previous example, but when I have two angles, remember the easiest thing to do from here is to find the third angle, since they all add up to 180. So I know 50 and 61, that's 111. I subtract that from 180, and I get my third angle is 69 degrees. And now I have an angle and a side across from each other. So then as soon as I have an angle and a side across from each other, I go to law of sines. The 69 is across from the 12, so sine 69 degrees over 12. And then I can pick whichever one I want to find. Say I wanted to find H. So I would say sine of 50 degrees over H. And then I cross multiply and solve, just like the previous example. Fourth example, here I have all three sides. Now notice law of sines has two angles in it. So there's no way I can use law of sines with no angles. So instead I use law of cosines, and I can use this. I have my A, B, and C, so I can find any angle I want. Let's say I wanted to find angle J. Then what I would do is start with side J by saying J squared equals, or in this case the 17, so 17 squared equals, and then 22 squared plus 18 squared, minus 2 times 22 times 18, and then cosine of the angle I'm trying to find, so J, so cosine of J. And then remember, to solve this one, I can't type it all in the calculator because I have this undefined J over here. So instead I start by doing those two. 22 squared plus 18 squared is 808. Then the 222 times 18, so negative 2 times 22 times 18 is negative 792 cosine J, and that's all equal to 17 squared, which is 289. And so to solve from there, to get J by itself, I'm going to cancel out all this. So I'll start with the 808, subtract 808 from both sides. So 289 minus 808, and I get negative 519 equals negative 792 cosine j. And then divide by the negative 792. Divide by negative 792. I get this decimal, 0.655 and so on, equals cosine of j. And then without rounding, I want to do cosine inverse to cancel out that cosine. So I will do cosine inverse of my answer, and I get 49.057, so j is 49.057 degrees. All right, final example over here is where I have an angle followed by two sides. So this is the angle side case. Notice I do have an angle and a side across from each other, so I can use the law of sines. But when I set it up, this would be sine 58 over 14, that's degrees, equals, and then 10's the only other side I have, so that has to go across from the O. So that would be sine of O over 10. But because in this case I'll be solving for an angle, I'll have to do sine inverse. This is where I have to consider my two cases. So this is when we might have the ambiguous case, and I would have to check that.